In this video, we will be reviewing 5 questions that cover target 3B. We're going to start with this first one, move on to the second one, a third, a fourth, and a fifth one. So back to question number 1, we need to solve for x, and we can do this algebraically. The first thing that I want to look to do is get this x squared by itself. So I'm going to take away 19 from this side. That cancels it out. We're left with 0. We have to do the same thing to the right side. So now we're left with an x squared equaling negative 19. Okay, now we want to undo the squaring of this x. So what we can do there is take the square root of this, and then we have to take the square root of the right side as well. So now we're left with just an x, and whenever we take the square root of a variable being squared, like in this situation, we have to write down plus minus, okay, because there's going to be 2 answers, and I'll explain that in a minute. And then now we have a negative 19 underneath the radical. So back to why we have to do plus or minus. If you have, for example, x squared, and that can equal 9, right? So what could you plug in for x to make this true? I know that we could do 3 squared. That gives us 9 because 3 times 3 is 9. Well, you can also do a negative 3 squared. That's going to give us 9 as well, because if we do negative 3 times a negative 3, again, like I just said, we have a positive 9. So there's the positive version and then this negative version here. So that's why we have plus or minus. Now, we cannot have a negative underneath the radical. So what can we do there? Well, we rewrite x equals plus or minus, and we're going to break up this radical into 2 separate radicals. We're going to have negative 1, and it's the square root of negative 1, times the square root of 19. You almost like take out that negative 1, and then we could rewrite that using an imaginary number. That's just going to be I, and then we're left with the square root of 19 underneath it. Well, not the square root of 19 under the radical. It's just the square root of 19 with that I, and then plus or minus. So can't break that down anymore. Let's move on to the next question. Solve for x here. We have a trinomial. We could solve it any way we want. For this problem, let's do it by completing the square. So to complete the square, we want to get rid of this positive 39 by subtracting 39. So that goes away. And then I'm left with x squared plus 4x. And that's going to equal negative 39. Now the whole reason we did that was to get my quadratic term here and my linear term by itself. Our next step is going to start the complete the square process. So I'm going to rewrite x squared plus 4x. I'm going to leave a little opening there. We're going to add something in. We have negative 39 on this right side, and then we're going to leave a little area to add in something over here too. So now what we have to do is take the coefficient of our linear term right here, which is the term with the x. We take that number, which is 4. We divide it by 2. That gives us 2. And then we take 2 and we square it, which gives us 4. That's going to be the number that I add to the left side, and to keep the equation balanced, we have to add it to the right side as well. Okay, now we can factor this. The 2 numbers that multiply together to get a 4, but also add together to get a 4 here, is going to be 2. So you'd write this like x plus 2, and then x plus 2 again. And then negative 39 plus 4 is going to be negative 35. Because we have 2 binomials that are identical being multiplied together, you could just write that as the quantity of x plus 2 being squared, and that gives us a negative 35 still. And this is right where we want the equation, because whenever we have something being squared, we could take the square root of it. So let's take the square root of this part here. We got to do it to the right side as well. And now we're left with just the x plus 2. And that's going to be plus or minus the negative 35. Now that's underneath the radical. keep solving now. We got to take away this 2. I want to get x by itself, so we subtract 2 from the left side. Means we have to subtract 2 from the right side as well. We're going to be left with x, which equals -2 plus or minus. Now, we can never have a negative underneath the radical, so we have to do something with that. We're going to take out the square root of -1. We're left with a positive 35 underneath the radical. Simplify this just a little bit more. We'll have x equals -2 plus or minus this square root of -1 becomes I, and we have the square root of 35 after that, and that's going to be our final answer. On to the next question. We have to solve again, and this is really similar to our last problem, but we want to get this. Well, here, let me go back here. We want to just get this part right here in parentheses that's being squared. We want to get that by itself. So let's take away this 50. That goes away. So we subtract 50 from this right side. We're left with x minus 8 being squared, which equals -100. Now we could take the square root of x minus 8, and I was going back to this problem here because this was the part that we wanted to get it to, because once we get the binomial squared by itself, we can take the square root of it. So back to my other problem here. We want to take the square root of this, so there we go. Do this right side as well. We're left with just an x minus 8. Because we took the square root of a variable that was being squared, we're going to have a plus or minus, and then it's going to be the square root of -100. Keep solving, so we want to get x by itself. Again, add 8 to this side, which cancels out the -8. Means we add 8 to the right side as well. We have x equals 8 plus or minus. We don't like that negative underneath the radical, so we're going to take out the square root of -1, which leaves us with a positive 100 underneath the radical. This square root of -1 becomes an I, and then the square root of 100 is 10. So this is going to be our final answer. Keep cruising here. So now we have a word problem. We have a few students here that are describing the solutions to this equation right here. So let's go ahead and solve it and figure out, if we have one solution or two solutions, or if they're real or imaginary. So I'm going to rewrite my equation here, and we want to get our x squared by itself. So the first thing that we do is take away 252. That goes away. We're left with 7x squared equals a -252. We want to then divide this left side by 7, because then 7 over 7 is just 1, so it cancels out there. We divide this right side by a 7 as well. We're left with x squared equals a -36. Now we want to get rid of this squaring, so we take the square root of it, which takes the square root of this right side as well. We're left with x equals, because we took the square root of a variable being squared, we have to put plus or minus, and then we're doing the square root of a -36. Now automatically we see that we have a plus or minus, so that means we have two solutions. And then we have a negative underneath the radical as well, so whenever we have that, we know that we're going to have imaginary solutions. So who guessed that we had two solutions that were going to be imaginary? Looks like Evie says that the equation has two imaginary solutions. Okay, on to the fifth and final question. We have Lila and Trisha are solving the following equation. Figure out who is correct. So let's take a look at what we had right here. First, to solve this, we would want to get the x to the fourth power by itself. So we want to add 256 to the left side and to the right side. And then we'd be left with x to the fourth, which equals a positive 256. It looks like there's a negative here, so that's automatically wrong. That's going to be making our answer incorrect. Let's see, what else can we look at? On this right side, Trisha, she added 256 to both sides. She got the correct positive 256. Then she took the square root of x to the fourth, which gives us x to the second power. She did the square root on this right side as well. That gives us plus or minus 16, which is correct. And then whenever you take the square root of a variable higher like that, you have plus or minus. She separated it into two different parts because we had a positive version and a negative version, and we did not do that over here on the left side, so that could be another mistake. I'll go ahead and write down there wasn't a positive and negative version. Okay, somewhere in there should have been a plus or minus, and that could be another error for this part right here. So that's about it. Let's recap. We'll go back to our first question. We were solving for x. Second one, again, we are solving for x. We solve by completing the square. And you could solve it a couple different ways too. You could probably use the quadratic formula as well, but moving on to the third question, again, we solved using some algebra. On to the fourth one, we figured out what type of solutions we had. And then the fifth question, we determined our error. There was a small addition error here, and then we also forgot about the two possible answers, the positive version and the negative version as well.